Okay, I'm back, and now I'm going to add the letter R to our list of properties of a star that we can measure. And now we're going to talk about yet other properties that you can get from its spectrum. So we already mentioned that you can figure out the temperature of a star by looking at its spectrum. So we take our diffraction grating, we attach it to our telescope, we look at the spectrum of light that's being emitted by that star, and then we analyze it. And we said that one of them was we could figure out the temperature, the surface temperature, by looking at where does it have its maximum at. Well, another thing we could do is look at the width of the lines. Now, we already did this. So if you recall back in unit number 1, when we were talking about light, we already talked about how to use the spectrum in order to figure out these things. So I encourage you to go back to unit number 1 and look at those lessons where we talked about this. But when you look at the lines, the emission lines produced in a spectrum, sometimes you're going to notice that that those lines sometimes are thin, and then other times those lines are very thick. And so the width, the thickness of the lines, we found out would tell us something about the turbulence going on inside the star, and we figured that out by using the Doppler effect. We could also figure out the rotation rate of the star by looking at the width of those lines. And then you could also figure out the density of the star, and you could also determine the strength of the magnetic field of that star, all by just looking at the width of those lines. And then we could also look at whether those lines are shifted, and we called that the Doppler effect. And so if this is where the lines are in the ordinary laboratory, but then when you look at them through your telescope, it turns out that this line is over here, and this one's over here, and this one's over here, and this one's over here. Well, they've been shifted. And if this is your normal spectrum, where this is lambda over here, so the bigger wavelengths are in that direction, so therefore the wavelength got larger, and so we say that it's being red shifted, and so that means that that star is moving away from the Earth. If the lines are over on this side, then we say it's blue shifted, and then that star is moving towards the Earth, and we can actually calculate how fast it's moving. So we're not going to get into it, but I just want you to know it can be done. All right, we're going to take one more break, and when we come back, we're going to take a little quiz.